Hi. Hello. Uh, right, I'm doing streaming. That's what's going on. Okay, so last time we got the monitor working a little bit better. I'm calling the monitor closed for now. It does what we need it to do. We can write bytes, read bytes, dump multiple bytes. What else can we do? Oh, we haven't tested it yet, but theoretically we should be able to jump to code and execute it. So that's most of the things. Now, the whole point of that was to be able to just futz around sending commands and whatnot to the floppy controller. So that's pretty much what we're going to do today. End of yesterday's stream, I tried sending the version command and it didn't quite work. I'm not sure. We might have to do some hardcore reading the documentation today because I think there's a real possibility that like the controller will time out if you don't do the phases of command execution in a timely manner. I might be totally off on that, but I just have this sinking suspicion that if we try and do it by hand, it'll give up on us after a little bit. So what I want to try and do is start by doing the version command again in case I just missed something insanely obvious yesterday, sent something wrong, or something like that. And once we have tested that out, if it does or doesn't work, if it doesn't work, then I'm going to try just writing a little short machine code, bit of code that will do it automatically in software, which would presumably prevent it from being any kind of timeout sort of issue. So let's do that. Okay, so over to here, and everything should be working. There's our beautiful, beautiful monitor. And our floppy drive controller should be hardware reset now. And if we, let's see, I have to remember my commands again now. So if we go 6802 was the address of the digital output register, I think. We will know, because if we write a 10 to it, it will turn the drive on. Okay, cool. I am remembering things correctly. So, 6802. Let's write 04 should be the reset this thing command, which, yeah, that seems right. And if we read 6802, yeah, it shows when that bit is high, it means it's not in reset state, I think. And you know what? Just to be extra certain, you know what I'm going to do is I'm going to actually do this. I'm going to put it to 1 and then put it to 0 and then put it to 1 and then put it to 0 again. Or other way around. 0. I'm going to reset it to 0. I'm just going to put it through its full reset paces at least once, so I can be pretty sure it's fully reset. So 6802, whoops, 6802, and we will set the address and write 00 to it again. Then 6802, write 04 to it, and then 6802, write 00 to it again. Okay. Dang it. 6802, 04, because it is not in reset when that is high, right? So we should not be in reset mode now. And as such, let's try sending the version command again. So let me look that bad boy up. Hello? Hello, desktop capture? Are you there? Hello? Oh, I wonder if it's because when I changed my monitor. Yeah, it is. because sometimes this TV turns off, and then it screws up everything. But we're good now. So, let us look. I'm going to look at the OS Dev page, because scrolling through that PDF is just painful if I can avoid it. And, all right, the version command is OX10. Mike Woodall said, I am finally caught up and now catching you live. Thanks for catching me live, and good lord on your perseverance trying to catch up. I don't know whether to congratulate to you or apologize, but he says, love your work. I appreciate it. It's pointless and silly, so I hope you enjoy. We're just trying to send some commands today. So this tracks with what I remember being the case, which is version command is 10, and then I should basically just read it, and it should give me back 90. And you know what? Let me fully read that reset and issue a command situation. Excuse me. Where was reset? Because it has reinitialization. I passed that. I know I saw that. Now I'm into commands. Come on. Detecting media drive selection. Controller reset. So we used the bit 4 and the DOR. Yep, so write a 0 to the DOR, wait a minute, then, I mean, hopefully that I think it needs to be at least 4 microseconds, which, of course, it would be, because I'm doing it by hand. Then write the original value back to the DOR. Bit 2 is always set. That is what I did. It should be written back now. Wait for IRQ6, which we can't do. I don't know how to check. You think I can check to see if drive polling mode is on right now? I don't know. I guess let's try sending 4 sense interrupt commands just in case it is in drive polling mode. I don't know what the default setting is when it comes up. So I guess let's try that first. No, well, first I will try this check version command again, make sure that it doesn't work. And then try again. So, FIFO. That is going to be register 5. Right to register 5. Trying to do the key combinations to change my screen on the NES. That's not going to work. All right, so 6805, and then we are writing 10. That is the version command. Then read 6805. Just read it. And I am fairly certain that says 80. Which ain't right. Yeah. A 9 and an 8 are pretty significantly different looking. Just making sure. And let me look at my chip to just make sure it's the version I think it is. It is an 82077. That is the chip I'm looking at the documentation for. All right, let's try resetting again. Excuse me. And doing that whole full reset procedure again. And I guess try sending the sense the interrupt sense commands. Excuse me. Yes. So this is just 6802. Write a 0, I guess. 6802. Write a 04. Just to be super careful. 6802 00 6802 04. And that should be quite reset now. Now let us send. Let's read the master status register firstly for fun. So 6804. Read that. And that should be 808 says, please send me a command, sir. And so let's send the Yoodly Doodly. What am I looking at? I am looking for something. No, wait. Oh yeah. The IRQ sense command, sense IRQ. I keep not being able to controller reset. Right there. Also says wait for the resulting IRQ6 unless you have IRQs turned off in the DOR. So I might want to do that. I want to double check that. But yes, sense interrupt commands. So let's see if it has the list of sense interrupt command. Sense interrupt, sense interrupt, sense interrupt command. Here we go. Oh, how about you look at my screen, huh? This command's main function is to return any error code from a seek or recalibrate command to your driver. It also clears an internal bit flag in the controller. It is required in 3 circumstances that produce interrupts: after doing a controller reset procedure with drive polling mode turned on, after the completion of a seek command or relative seek, and after completion of a recalibrate command. These are the only times when you should send a sense interrupt. You should still send them even if you have IRQs turned off in the DOR and you are using PIO polling instead. If you send sense interrupt commands at other times, the command will complete, return a 0x80, and then lock up the controller until you do a reset. So the command is 0x8, and then we should just be able to read it. Oh, and there's 2 result bytes. What is STO here? There are 3 registers that hold information about the last error encountered. The STO register information is passed back with the result bytes of most commands. Okay, so it's just letting me know that that is going to give me the status in the first result. I guess let's go ahead and send that and see if that does anything better for us. What am I doing? So I want to write 6805, and the command is 8, so 08 write. Then, ooh, let's check the DOR now. See if it says I have something I wish to send you. Not the DOR, the master status register. 6804. Dump it. What is going on there? Oh, it's D0. I can read. Planning on loading software larger than standard NES ROM package limits by the floppy disk? No, just loading BS via floppy disk because I potentially can for no good reason. This is a project to turn an NES into just a bog standard 80s home computer, even though this would be a pretty good floppy drive for NES days. Micro floppy really was just beginning to be a thing when the NES came out. But it's what I have. Okay, so Yes, D0. Is that a reasonable value? What is D0 going to be? Is that 1100? Which would be good. You'd think I'd have my hex numbers memorized, but especially on camera, I certainly do not. But we can print it in PowerShell because PowerShell, yeah. So that's 13, and that would be 8, 9, 10, 11, 12. Oh, so is D 1011? Boy, I should have these memorized. It's very easy. 1, 2, 3, or 8, 9, 10, 11. No. So is it 8, 9, 10, 11, 12, 13? Yes. Okay, so I think that's good. I think it's saying we have a byte to read, which would be correct. I'm not sure. Let's check out what that fourth bit there is, just to be sure. Master status register. What do you say? Master status register says, command busy, set when a command byte is received and cleared at the end of a result phase. So I think that's also right. So let's cross our fingers and see if we get a valid status register 0 value. Let's see. So 6805, set that address and dump it. It says 80. I don't know if that's the right value, but there are 2 results here, so 6805, set the address, dump it. Also says 80, which kind of makes my heart sink because that is probably not even remotely right. Let's check the master status register again. Master status register. 6804. Set the address. Dump it. Interesting. It still says D0, so it's like still waiting for me to read stuff. I guess I'll keep doing that then. 6. Oh, come on. Did I kill it? Did I kill it? Did I kill it? Oh. Enter key is held down. That'll do it. 6805. Just keep dumping it. 680. Yeah, let's just keep dumping and then checking the master status register value. Okay. Is that 80? I can't read, and it's rather fuzzy. 6804. Yeah, so if that is indeed, yeah, that looks like 80. Sorry. Broden Studios Twitch TV VOD says, I've done much just because I can over the years. Good on you. That's a way to live. So, it says it's ready for another command to be sent. That's interesting. I guess let's look at ST0 and see if 80 is a valid value for it. Okay. ST0 says top 2 bits are set after a reset procedure with polling on. Either bit being set at any other time is an error indication. Bit 5 is set after every recalibrate, seek, or implied seek. The other bits are not useful. Interesting. So, I mean, what does this even tell me? Okay. Huh. All right, so it says, if you try to read the result bytes without waiting for RQM to be set, then you are likely to always get an incorrect result value of 0, which I have never seen. This is also likely to get your driver out of sync with the floppy drive. Sure. The correct value of ST0 after a reset should be 0xC0. Ordered with the drive number, which I don't think I have a drive selected right now, so that should be 0. So that should be C0. It is not. So I got no idea. I got no idea. So what should I do here? Maybe I'm going to look at their example code. Code examples. Reset floppy. Interesting. What's up with that being C when they're resetting? Because I was not using C, I was using 4. So why are they writing C to the DOR to do that? Let's see what that would do to the DOR. So that would be, what, 8, 9 A, B, C. So that's 1, 1, 8, 9 A, B, C. Yes. Yeah, because D also has this bit set. So, wait, sorry, but it's the low one. So sorry. It is IRQ and reset? Oh, because they're enabling IRQs. Okay. I don't want IRQs enabled, so that's fine, right? Note, the IRQ DMA enable bit 3 value 8, cannot be cleared in PS2 mode. Really? So for PIO transfers, you should make sure to have a stubbed IRQ6 handler, blue. Interesting. How's about I try that? Because firstly, now this makes me a little suspicious because they say you can't turn it off, but I've never seen it be on. And theoretically, I have configured this controller for PS2 mode. So, that's weird. But why don't I try exactly mimicking this floppy reset command and see what's up? Because I'm curious. Okay, do it manually. Let's see what we can see. So I'm going to do a full reset of the hardware and do exactly what they say. So I am going to 6802 is the data output register, right? I feel confident about that. 6802, write a 00. Then 6802, then they wrote the 0C. Then they waited for an IRQ to show up, which I think I can do via, let's see. Sorry, I'm reading off screen. Just wait for me. I know there is a flag for IRQ happened, and I'm going to check for it. Come on. Where is the register names? They have disappeared on me. Okay, this is taking long enough. I will switch you over. Come join me. What happened to my register names, or my register things? It gives DOR bit flag definitions. It gives MSR bit flag stuff. I feel like it was NDMA. They're describing it weird, but it says set an execution phase, but it doesn't say what it is. NDMA signals the end of the execution phase of the command and the beginning of result phase. Which is when it sends the IRQ, right? Yeah, I wait, no. I swear that there is a bit. All right, we're going to the PDF. God help us. God help us. Because what I want to see is, I know there is a register that says an IRQ has happened. And I just want to make sure it actually gets set. But maybe I'm just going insane. Int pending. Yeah, there we go. Not in Model 30 mode, though. Yes, PS2 mode. Int pending. Yeah, the int pending bit is used by software to monitor the state of the interrupt pin. Yeah. So anyway, regardless, should be, if I read status register A, that should be set right now, I believe. And status register A is at address 0. So, right, so it's supposed to issue an IRQ when it's done resetting. So it should be issuing an IRQ right now. Let's check it. 6800, dump it. 96 seems right. Let's see. 96 would be int pending would be set, and so would well, this one would not be set. Let's see. Track 0. What does that one do? Tell me what it does. Tell me what it does. Oh, they reflect the floppy disk drive input pins. So, I don't know. But apparently that's set, because it's, first one is 9. So it would be int pending and track 0 being set. So apparently we're not on track 0. Interesting to note. And then what was it? It was 96? Oops, 96. So this one should be 6, which would be index, which I don't know what that is, and dir, which is controlling probably, I think, which way the head is supposed to be moving. I don't know. They reflect bits on the pin, but theoretically shows interrupt pending. So I think that's right. That's all I wanted to see, is that it says it should be sending an interrupt when reset is done, and it says one is pending. So neat. Doesn't really say how to clear or respond to an interrupt, so that's a thing. Let me dump it just one more time, just to make sure it stays at 96. Okay, so it's definitely 96. So it's definitely saying it didn't clear the interrupt status by reading it or anything. That is not what it did. Okay, so back to reading their code, and actually, because they had in their example code, they have an IRQ handler here, and it doesn't really do anything, like as far as sending anything back to the controller. So I don't know if you just indicate to the controller that you are responding to the interrupt and it's done and it's handled by writing a command. Yeah, but let's do this part now. Wait, no, we did that part. So we did this, then we waited for the IRQ, and it's high. So I guess now let's just do this 4 times. So that is 6805. Since interrupt was 08. And then we do 6805. We read it. 6805. Read it. And we do this 3 more times. 6805. Send the sense interrupt command. Oh. Ah, shit. Shit. 6805. Send the sense interrupt command. 08. Write it. Read twice. 6805. Dump. 6805. Dump. Goddamn sticky keys. Okay. Hopefully that being triggered on several different addresses didn't screw anything up too bad. Boy. I should just write code for this. I was told to make a monitor. It will make your life easier. It seems to be a struggle. Okay. Good lord. Because see, like, have I... No, I've only read it once, right? Yeah. Yeah, this is fun. 6805. Set the address. Read it. Okay. 2 more times. 6805. Set the address. Write 08. 6805. Set the address. Dump. 6805. Set the address. Dump. 1 more time, I think, if I can count. 6805, set the address, send the command 08. 6805, set the address, dump. 6805, set the address, dump. Okay, I have done what you told me. Sure, I'm gonna do all the stuff they say. So they then say output 0 to the CCR register, which apparently sets the drive bit rate, which is what we want for a 1.44 megabyte floppy. Sure, let's do that. Which addresses and which register is CCR? CCR is, come on, work with me here, CCR. CCR is configuration control register, and that is the register at 7. So, they send 0 to the CCR. Why don't we just go ahead and do that then? .6807, set the address, write 00. Very good. And then the next thing they do is they do a specify command. All right. Specify command is, let us look. Specify? Hello? Specify? Specify is command 3. So we should be able to send a... let's read from the status register, make sure it's ready for us. Why would it not be? 6804, set the address, dump it, says 00. Huh. I dislike this. Okay, here's what I'm gonna do, because I'm getting sick of doing this manually. As cool as it is, I have a monitor now. No, this is getting absolutely ridiculous. So I am going to reset this thing hardware-wise see what that interrupt status is when you turn the thing on, because I don't have the interrupt line hooked up, so I need to detect interrupts in some other way. So, yes, reset the whole hardware, see what, after a hardware reset, the interrupt flag is set at, and hope that it is 0. And then if we can use that to detect the interrupt, I'm just going to copy this startup code that they have over here into assembly on this freaking EEPROM. And we're going to see if after doing this whole procedure, things look better in the monitor vis-a-vis trying to send commands manually. This ain't working. And I probably should have read more in the documentation, but I still have that sinking feeling that it doesn't like timings this slow. Maybe that's just me being paranoid, but that's what I'm feeling. So, all right, reset it. See if that interrupt flag is 0 at startup. 6800, I believe. Dump it. Yeah, cool. It is cleared. Because otherwise that would be a 9. Let's write this code in assembly. Let's do it. Let's do it. I'm not messing around no more. All right. Hello, good old friend VS Code. Would you like to help me out? Where is my entry point? Where is my entry point? Well, it's called entry, so it's got to be pretty easy to find. Right there. So I am just going to jam all of this code into right before we call into the monitor. That's what I'm going to do. So right here, initialize the FDC. Cool. Fine by me. So first thing we do is write 00 to the DOR. Okay, that's what we're going to do. Even though I think that's redundant because it starts up at 00, and we know we just did a hardware reset, but I'm going to do what it says here. So DOR is, let me be real careful. Firstly, load A, 00, and then store A to, I believe the DOR is 6802. Let us double check that. 6802, 6802. DOR is, yes, register 2. So we wrote 00 to, we did this line. Done. Then we'll write 0C to it. Right here. Load A, literal 0C. 0C, thank you. Store it to 6802. Okay, that's both these lines. Then we wait for the IRQ. So that should be load A. That was 6800 status register A. And we will, let's make a nice sexy label here. Wait, IRQ. All right, so I'm going to AND this with 80 and branch if 0 to wait IRQ. So that should loop us until such a time as that bit in the 8 position goes high, indicating that an IRQ was triggered. Alrighty. And now I guess I just do these things. So let's do send command properly, because we're doing this in software. So we're actually going to need to check things. So the first thing we do is we wait for DOR's top 2 bits to be, let's see, wait, let's call it wait. Well, 2 things. Let's load x for, I want to loop 4 times, and our top loop will be send next sense int command, and the first thing at the top of that loop, well, I guess I'll just use that label again, but it's gonna want to just loop straight back up. We're gonna read the DOR, load a, or not the DOR, the master status register, which is register 4. Let's also make dang sure about that. 6804 6804 444 for main status register 4. So we will read that, and then I will and against let's see, I want it to be, I want the top bit to be 1 for sure. Well, I know I want to check those top 2 bits. So it should be until bit 1 is, or the, sorry, bit 7 is high, and bit 6 should be low, I believe. Let's find out. Really? MSR. Bit flag definitions. Set if the I/O port expects an in opcode. Huh. So I'm going to go ahead and read the PDF on this because that is all very... What? What are you saying there? An in opcode, huh? Main status register. That is, yeah. So DIO indicates the direction of a data transfer once RQM is set. A 1 indicates that we need to read, and a 0 indicates that we need to write. So it should be 0. That's what I thought, but they couldn't just write it in the OS Dev Wiki in a sensical way. That's why I'm using 2 documents at the same time. Regardless, this is going to be, we already agreed that's C, right? CO is the top 2 bits, right? I clearly can't do this tonight, so 8, 9, ABC, yes. And then we will actually compare that against a literal 8.0, because we want the top one to be set and the other one to not be set. And if it did not equal that, then we jump back to send next sense interrupt command. Cool. So that will loop until it's ready for us to give it a command. You know that the first thing that this code is going to do when I actually execute it on here is just hang, and we'll have no idea why, because whether it's waiting for the IRQ or trying to do this bit, yeah. And then we'll just disable stuff until we figure out where it is. But yeah, I guarantee you that's probably going to happen. Guarantee you, probably. Right, so that is the part where it waits for it to be ready to send a command. Let me make sure, because that's one thing that is not explicitly written out in that code. They are best practices for sending a command. Proper way to issue a command. Read MSR. Did it. Verify the RQM. Yeah, so value n0xco equals 80. Send your chosen command byte to the FIFO. We just do it. All right. So since interrupt was 8, so load a literal 08, store it to 6805, the FIFO. And then, in a loop on reading the MSR until RQM equals 1 again. Basically the same thing, I guess. Okay, whatever. We'll just make another loop. That's fine. Wait on it was RQM, right? RQM. Wait on RQM. And then we just do that same thing again. Load the status register 6804 and C0. Compare against 80. And if it was not 80, we jump back to wait on RQM. Same deal. Okay, and then we're going into the next phase. I don't think this command has an execution phase. Doodly-doo. Or the command does not perform movement operations. It does not. I think I can skip this part, he said, probably dooming himself. Read MSR, verify NDMA equals 1. If it's not set, there is no execution phase, but I think I'm safe to say there is no execution phase. Okay. And then that just brings me to the next part, which is pull MSR until RQM equals 1. Okay. What? See, this is why it's either written too simplistically and in a kind of confused way over in the wiki, or in the documentation it's written too verbosely. And both are not helpful. I mean, are helpful in their own ways and are hamstringing me in their own ways. So, yeah. Let's see. So let me just read this whole thing. Take my time. Either pull MSR until RQM equals 1, or wait for an IRQ6. Then in an inner loop, transfer a byte in or out of the FIFO. In or out. Okay, whatever. And just keep on repeating that while RQM equals 1 and NDMA equals 1. Okay. Which direction should I transfer? I mean, I guess it's based on the direction byte. If NDMA equals 1, loop back to the beginning of the outer loop unless our data buffer ran out. I mean, this has got to be for, like, mainly for, like, transferring sector data and stuff. Bigger things. I'm going to guess this goes straight to result phase. Oh, yeah, I think this whole section is execution phase. Yeah. That's okay. So I'm going to ignore that, because I don't think this has an execution phase. Result phase begins. We're not using DMA. And then this is just indented for no reason. Okay, it's not even related to this. Loop on reading MSR until RQM equals 1. Verify that DIO equals 1. Okay. Oh, so like this step I shouldn't do, because there is no parameter byte here. So I should also be skipping that step. Okay, so I think I can just jump straight up to here. Instead of comparing this to C0, it should be just 80 again. Or wait, no. Hold up. No, I and it with C0, and then I want the result to also be C0. I want it to be telling me that it has something it wants me to read, which is what DIO is. And then read the next byte. Read until RQM equals 1. What? Read the next result byte from the FIFO. Loop on reading MSR until RQM equals 1, which is confusing and probably confused because RQM equaling 1 means that there is data. Oh, well, it's waiting for a command to be written to it, but if it was waiting for a command to be written to it, DIO would be 0. Okay. I mean, I guess I'll do it anyway. We'll read the result byte. We'll do that part for sure. So load A from 6805, and that will put the result byte in A. And I mean, we should really probably stash that somewhere. I'm going to put it in the 0 page so that way. Oh, wait, no. I'm just trying to reset the damn thing. I am not trying to send the version command. So I'm not going to store that anywhere. I don't care. So load A 6805, load A 6805. Shoot. Because also, really, I have to... I have to do this twice. I'm just going to unroll this loop, okay? Just to make my life easier. Wait on RQM2. Same shit. Okay, so those are my two. I mean, I said I got a little sidetracked because I said I'm going to do exactly what they do, and what they do is they send the command and then. Oh no, wait, no, they don't just do an INB here. They do a read data byte subroutine. So these will be my read data byte subroutines. Okay. Okay, fine. And then I need to do that 4 times is the trick. So finally, let us decrease x and branch if not 0. Yeah, there we go. Back up to send next sense int command. Cool. Cool. Fine by me. Now. How much more do I want to do? I guess it's not like this is that much more difficult. So let's do the whole thing. So after we've done 4 of those, write 00 to the CCR, which I believe is, so load A00 and then store that to what I believe is the CCR 6807. Let us check the doc. 6807 CCR. Tell me about it. Tell me about it. Why can I not ever find the frickin' table? CCR. Yeah, 7. 7. Right there. Right over here. So we load 0, store it into CCR. Cool. Then we send specify command. And I'm just going to configure it exactly the way that they say to. So we're going to send the specify command, which is specify is 3. Now we have to do this whole send command thing again. Let's see. So I'm going to copy most of this code. Load A 6804, check to see if it's ready for us. Otherwise loop. Then load our command, store it, and because like the fun thing is this doesn't even like do a special write data byte thing. It just sends the command and then outbees them. So that's fine. I think I will go ahead and wait. Well, I mean, what are you gonna do? I think I'll steal this much, wait for it to be ready for us to send a command. Then I'm also gonna steal this much, but I'm gonna change it around to wait until it's ready for, until it's 8-0 again, waiting for us to send it some bytes. And now I gotta rename everything. So we don't need this as a label. Wait, no, sure we do. Wait. Let's just keep doing this. Wait on RQM3. See, at some point when we put this in a subroutine, it's gonna be a lot better. I'm telling you. Then we send our command, which is the sense command, which is 3. Then we have, let me properly indent this. There we go. Then we have wait on RQM4. 4, please. In which we check for 8-0 again this time, because we want it to say, please give me command stuff. And then now that we have done that, since they don't wait, let's just also not wait. We will outb load a whatever this value is going to be, which, I mean, now we're going to have to look this up, because where is this even defined anywhere in here? Step rate head unload. Are they just telling us that we need to set the step rate and that head unload? I don't know. Let's look up the specify command. Surely that is specified in here. Specify. So the first parameter is whatever SRT value is and whatever HUT value is. Cool. And then whatever the HLT value is. And, they're probably written right here in this SRT, HLT, and HUT thing. Yeah. Chat is keeping up. These parameters are sent with specify command. Step rate time. Time the controller should wait for the head assembly to move between successive cylinders. A reasonable time to allow for this is 3 milliseconds for modern 3.5-inch floppy drives. A very safe amount would be 6 to 8 milliseconds. To calculate the value for the SRT setting for the given time, use SRT value equals... Let's just... For a 1.44 megabyte floppy and a big fat 8 millisecond delay, just use 8. That's what I'm going to do. So that's going to be 8. Head load time is... We're going to just use 5, and head unload time, we're just going to... However, it seems likely the smartest thing to do is just set the value to 0. Head unload time. Time the controller should wait before deactivating the head. I don't know. I'm just going to use what you tell me. So 8, 5, and 15. And that was, let's see. If your driver will be using DMA to transfer data, set the NDMA bit to 0. If using PIO, set it to 1. Cool. So SRT was going to be, I've already forgotten, SRT was going to be 8. HUT was going to be 5. So that is, I mean, that's just 8 and 5, I guess. Yep, that's going to be hex 85. So hex 85. And store that to the FIFO 6805. And then this value is just going to be 15 multiplied by 2, so that'll be 30, which is hex 20, or the NDMA bit, which I want PIO mode, so I will set it to 1. So what is going to be 21? Is that right? Well, that's what I'm gonna put. LDA 21. Store it to 6805. Okay, that should be a reset floppy controller, unless I did literally anything wrong. Totally possible. Or anything in their code was also not correct. Equally possible. So I'm just gonna... yeah. I'm just gonna build this and see if it hangs. That's what I'm gonna do for starters. Illegal addressing mode. Brilliant. 250. Oh, because those shouldn't be literals. It linked. That makes me feel very, very frightened. But let's see what it does. Let's just see what horrific thing it does to my poor, poor NES. Let's get the chippy out of the thing. Doodle 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 doo. Let's get the programmer up on the programming. Doodle 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 program. All right, are you gonna hang? Can you hang, Mr. Chip? I am still very tired today, so we'll see if this becomes a video where I, like, literally just turn it on, watch it hang, go, ugh, and then we're done for the day. That wouldn't be the lamest video that I've ever done, but it would be up there. Wow, look at that, it's hung. Who could have guessed it? Wow. Okay, let's just uncomment things until it stops hanging. Okay, so Bro10 Studios Twitch TV VODs says, which is a hell of a name, I wonder could you load Windows version 1.0 for 8088 CPU on NES via floppy? You would find that quite difficult seeing as it's a 6502 and not an 8088. Quite different. So I'm going to say no. Gerald is back, and he says, wait on RQM2 has an error. Oh, does it? Well, that's probably what's screwing us up right now. Thanks for pointing that out. If only I had read that when I was writing. And Zelsa says, damn, episode 35. Only 65 more until you're syndicated. Need to get you a theme song, though. I'm pretty sure it was at the end of the one video that blew up because everybody was very happy with it. And it goes, do, 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 do. I'm in my computer room doing some stuff. Something like that. That is the theme song. Just let's get someone to make like a good dubstep remix of that, and I'm down. I don't understand the 64 until you're syndicated thing, so you'll have to tell me on that one, because I don't know if that's just a joke about needing having a lot of episodes, or if there's some rule in some broadcast scenario where you hit 100 episodes and you get syndicated. Tell me about it. Okay. All right. Pushing on. I'm tired, but let's see about. Let's just fix that one line and see if it doesn't hang. You said it was RQM2, huh? Wait IRQ, wait on RQM. You are super duper right. Wow. Wow, neat. Yeah, that would loop forever, wouldn't it? Thanks for pointing that out. Okay, let's cross our fingers and maybe by some magic way that was the only thing that was wrong. program it up, program it down, program it left and right and all around. You gotta program the chip. You gotta program the chip. You gotta program it here and program it there. You gotta program it, baby. I just don't care. You gotta program it. And so we did. Before I press this, I just wanted to follow up that Zelsa says, 100 episodes is usually the minimum before a series will be considered for reruns, so most series secretly aim for at least that number. It allows for 20 weeks of non-repeating broadcast. Ah, that is very interesting, actually. I was hoping that there was some interesting, socio-industrial nerd info there, and I got it. Okay. It doesn't hang. So that means, the floppy controller at least, responded with the RQM bits in the way that one would expect. That's good, I guess. Broten Studios says, let's hope that's the only thing wrong. A programmer's fateful last words. Truer words were never spoken. Zelsa says Rahul, and hell yeah, no freeze. So that doesn't mean that initialization worked, or, that... I mean, I followed the rules, and it didn't blow up, and it didn't hang anywhere. So, yeah. And particularly where I would have expected it to hang is in those RQM checks, where DIO might not be in the right direction if something didn't happen in the right order, where, it expected things in the right order, because it expected an in, and then told us it wanted an out, and so on and so forth. And so we seemed to have followed that dance correctly. And that makes me feel good. So, what I would like to do now is, I think we can now do something as simple as I am just going to, again, I should really just take these wait on RQM loops and send command wait loops and put them in a subroutine. But I'm not going to do that quite yet. We're going to keep them unrolled, so I can just keep plugging on ahead, and maybe we'll have a cleanup day at some point here. But what I am going to do now is send the faded... just stealing this all again, that same way that I did before. Excuse me, the faded version. Wow. Scroll all over the place, why don't you? The faded get version command, and then just print what I get, and that will be that. And I think what I will do is, instead of printing it, I'm going to jam it into a 0-page location, and then when I get to the monitor, I'm just going to dump that location, because I don't know if the monitor will be initialized enough to do the print hex character call. It probably is, but I'm just going to do it the very safest way. So, what we should be doing here then is, as mentioned, let's see, what was I doing? Okay, so I should basically be stealing this, I think. Yes. So this is my send command bit. Whoops. And I'm going to call this wait on RQM version for no good reason. And our version command, I believe, was 10. And we send it, and then we will wait for, I guess just do one of these old guys. And we will want it to be... Here, I'm going to make it wait on RQM ver 2. Because you want to be consistent, you know? That's what you want to do. Whatever. But for this one, I will be expecting it to be waiting on us to read a value out. And then basically, we should just be able to load A from the FIFO, which should have the version number in it. 6805 is that good old FIFO. Then I'm going to store it at FDC version, which I am going to put at the 0 page. Let's see, we're going to have to shift a bunch of crap around now. I'm going to move these up to the rest of the 0 page definitions, just to keep better track of things. Yay, cool, fun. And I'm going to add the thing that I just called the thing, FDC version. We're going to put that at 0C. Shift these up, so this will be now at 0D. This will be at 0F. Everyone is happy. And if we get real lucky, then this will do the version command correctly, and it will save that version string to memory location 0C. So I don't know. Let's go for it. Let me read chat to make sure Gerald is not pointing out another typo on my part before I build. And Broton says, any day the 12-volt rail doesn't melt is a success. Also fully agreed. That's not a command. I am in need of sleep. It's only 9:46 East Coast. I don't know what's going on. I'm that. That's what I am right now. Is that I keep trying to... I'm gonna have to call this one pretty soon. I'm sorry. It is what it is. But let's build this and try and write the version and all of that, or try and read the version and all of that fun deal. Take thing, put it over in the other thing is what we do. Do-da-dee-do. And that'll work out just about right, because we are an hour 12 in, so I usually shoot for like an hour, hour and a half on a weekday stream. Well, they're all weekday streams now. I'm not doing weekend streams because I want to have a life. And I don't know if you know this, but I'm streaming every day, which leaves not much time for a life. Why am I doing this, you ask? Nobody's asking me to. That's a question my wife asks me on the regular. Okay, it's in the programmer. Let's do the thing. Mind you, she's fine with it. She just says, why are you stressing yourself out like that? And I say, I don't know. For the, 6 people that tune in and are regulars and are fun people to hang out with, it's worth it. We're the same people who would tell me, you don't have to do this every day, man. But I like making a little bit of progress at a time. Feels good. Did I even load the file? I'm pretty sure I did. I'm pretty sure you just watched me do that. But it never hurts to be safe. Cool. Stick it in the thing. Stick it in the thing. Stick it in the thing. It's the only way to know if the thing does its thing. And it's hung. Cool. You think that's a programming error on my part? Or do you think that is... Well, I mean, of course it's a programming error on my part. Do you think it's a typo? Or do you think it's a fundamental semantic issue? That's what the question actually is. I would prefer to not end the stream on a it didn't do anything. So, fine. So I think all of this was okay. Hopefully. I might want to do a test. I'm gonna scan my code really quick, see if there was anything obviously dumb, and then just make a if nothing is obviously dumb, then I will make a quick change to just jump over this code really quick without changing those 0-page values to make sure that moving those around didn't, for some bizarre reason, screw things up. Which I doubt, but it's worth checking. Okie dokie dokie dokie. Wait on ROM for. So, load 6804. Check to see if it's 80. Waiting for us to send a command. Cool, we loop back there. Then once it says, hey, please give me a command, we load 10, store it into the FIFO, and then we read the status register, wait for it to say, gimme, gimme, gimme them bits. No, wait. I'm gonna give you the bits. And we load that value and put it in the thing. That's literally it. I don't see a place that this would go wrong, at least not like in broad semantics. Do you? I don't. Oh, let me check something silly. I'm wondering. Oh, I'm going to be really angry if it's this dumb. If it's been this dumb this whole time. 1 second. 1 frickin' second. Okay. No. Yes. For a second, I was worried that the version command might be hex, or might be decimal 10. Because, you know, that would be dumb. And I am passing in a hex 10, which is 16, which is correct. Damn, I was hoping that that would be obviously right, or obviously swapped around, but no. It would be nice if there was a command. I mean, version is the command. That should just be the one for making sure everything works. And it has been a pain in my ass. And I was wondering if maybe there is another easy command that can like tell me if things are basically working, but that is the one. That is the one. So I'm going to break and read chat for a hot second. Zelsa says, I mean, as far as mental health crises go, streaming a neat computer project daily is pretty mild. Yeah, it's not so much about the like fixation of doing it daily, it's the stress of doing it daily causing a mental health crisis. Gerald says, sorry, had to answer the door, so missed your code, gotta go to bed, sorry, good night. That's okay, it's not your job, Gerald. As also says, good night, Gerald. Okay, Broton says, think it's a fault of instruction documentation. Fails from return null. There ain't no null, my friend. This is hardware and assembly. Ain't no such thing as a null. Null is an abstraction, and we don't have any abstractions yet. Oh boy. So it's odd, right? Well, let's just do the obvious and honestly, I guess start by just copying this line and moving it up before this line. Make sure I know that it is not for permanencies. Temp testing and see if this thing still hangs, even if I don't do that part. Because it could be that I screwed up those 0-page locations somehow. Program in time. No, back. Load stuff. Yes, here. At that address. get the... Oh, the chip is in there. Wow. Wow. Good job. Okay. It's probably still going to hang. Or it's probably not going to hang, would be my gut feeling. I feel like just trying to do this version command is sending it into a tailspin. Yeah, works fine. Of course it works fine. Because why wouldn't it? Why won't this version command just work for me? Why won't it just... Why can't you just work for me? Why can't you just work? Okay. You know what I'm going to do really quick? I'm going to go full, I hate writing floppy controller stuff, which is funny because I'm the one who put myself in the position of this project, but, and look up, let me see if it's on this page, because there is definitely a guy who has been around for forever on the OS dev community. Oh, well, also implementations. That's going to be useful. Because that's basically what I was going to say. Is let's look up an implementation and just see what they did. And I was going to say there's a guy who has what is a combination of his own simple operating system and basically a tutorial on writing that operating system hand in hand, and that would be perfect. And I feel like he has exactly what I'm looking for, but yeah. Oh, I think it's Broken Thorn. Yeah, I think Broken Thorn is the one I'm thinking of. Yes, it is. A lot of history, a lot of history, a lot of history. I'm not even nearly to the point of reading yet, so we can skip a bunch of that. Hardware stuff, cool. Waiting for an IRQ, which I can't do. Yep. DMA, which I am not doing. Registers galore. All of the documentation that I already know. I'm reading about the data register because I've got questions in the back of my head and I want to read this some more. So, this is an 8 or 16-bit read-write register. The actual size of the register is specific on the type of controller. All command parameters and disk data transfers are read to and written from the data register. Blah, blah. Before reading or writing in this register, you should always ensure it is valid by first reading the MSR, of course. All command bytes and command parameters are sent through this register. Yup. If an invalid command was issued, the value returned is hex 80. Which is what I've been getting over and over and over again. So that's fun. Okay, this gives us an idea of what he's doing for send command, which is literally just reading the status register, checking to see if it is set the way he wants, and then returning the value from the FIFO, or no, writing the value to the FIFO. And then for read, it's the same thing, but backwards. Waits for it to be ready, and then just reads in. So that is straightforward, and pretty much the same thing as I'm doing, right? Sure. Commands are used to control an FDD connected to the FDC for different operations like reading and writing. They are written to the data register over the data bus pins during a write operation. Sure are. Before sending a command or parameter byte, ensure that bit 7 of the MSR is sent, of course. There are 13 commands. Each command can be 1 to 9 bytes. That's cool. Here are all the commands. Wait. What? These don't look like the commands that I was seeing elsewhere. Now, maybe it's because of the smaller number of supported commands. Because it may be more. He says it's or more control depending on the controller. But does that mean? I mean, it says in the documentation for this freaking chip that version command is supposed to be supported. But what is read ID? I'm curious about that. What does it say over here? Because maybe it just doesn't like the version command for whatever reason. Okay. Read ID. Okay, that just generates an IRQ6. Fun. Okay. Generates IRQ6. Fine. Tell me more, oh broken thorn. Send a command to the FDC. Remember that we have to write it to the data register, the FIFO. Wait for it to be ready. I mean, here's just his send command thing over again. Extend command bits. I don't care. Gap, bytes per sector. I'm not even close to being there yet. I'm curious. I'm curious if the previous command really does need us to wait to write to the FIFO. You know what I mean? Because like here, he's doing floppy disk send command to send the parameters to a command, and we're not doing that because we just did like the example says and just send them without waiting. So do we need to insert more wait on RQMs? Because I'll do it. I will do it. I'm gonna do it. So like this one we did wait for it to say, give me more datas. However, this one we didn't. So why don't we just do that? And write, what's that? Yes, you're ready for it. Wait on RQM 5. Oh yeah, we're up there. And do the same old dance. Load 6804. And it with C0, you know it. And compare it with, oh yeah, hex 80. And if that wasn't what we wanted, well, then we're gonna break if not equal, branch if not equal. Wait on RQM 5. Yeah, there we go. And then finally, we write the value. Which matches Broken Thorn's code exactly, actually, because it sits here, waits for that to well, this loop is exactly the same as these two loops, and he's using his send command subroutine to send parameters as well. So, yeah, that seems like a good idea. Let's build this much and try it out, and leave this jump to init here to see if doing this will cause the thing to hang. Because if it does, then, you know, that would be an issue. And we should know that before we try pressing our luck too much more. So, to the chippy we go. It's already in the thing. I'm losing my mind. I already moved it back over, right? We did a whole thing. Like, I actually put it in there and we ran code and, Yeah, I vaguely remember that happening. I'm just going to assume it did and continue living my life. Program it up. Close the thing. Program it up. I saw Trey Dempsey got on in here. And so far Trey has said howdy and nothing wrong with cheating. Well, it depends on the context, Trey. It depends on the context. But I would probably agree with you. Okay, let's get this thing over here. Were you watching any of my screen during that? Because I feel like, did you not catch any of me programming? That would be cool. Okay, so it's happy with that. Let's see if that's enough to make the version command work properly. Remember that time I went to all the trouble of getting a monitor working? Took me 2 episodes, getting it dialed in the way I wanted, and then I didn't use it because it was too much of a pain in the ass. Pepperidge Farm definitely remembers. Okay, so we're doing the same thing now, and yeah, except that now we are allowing this section to happen. Good luck. Good luck. No, wait, yes. Wait, yes, it's in the programmer. We're ready for it. We're ready for it. We don't need to move anything. Load it. Load it again. Program it. Program it again. Back, done, cool, awesome. Move it, test it, see if it does stuff, see if it proceeds. I just want you to proceed. Y'all. Okay, so it got past issuing the version command. It told us that there was a value available. And I'm going to believe it. And that means, let's see, double check the address. That FDC version was supposed to be written to. That was supposed to be 0C. Now the monitor comes into its own. So set the address to 000C. And dump it. Stupid floppy controller. All right, that's correct. That is correct. So I'm going to cut it off because we are over an hour and a half in, but the version command is working. It's supposed to return us a 90. It's been returning us 80s this whole freaking flipping time, and now it's returning 90, which is what it's supposed to do. So I think I actually have the thing initialized properly. I've sent presumably 2 commands now, and I think that means that I can write myself a couple nice little subroutines for, you know, actually sending commands and reading values without having my loops unrolled 30 times. So I think that's where we'll pick up on Monday. Christian Voyager. Firstly, Zelsa says, hurrah. Thank you, Zelsa. Christian Voyager says, I was here for this momentous occasion. It was truly up there with, you know, the Ascension of Christ and me getting a 90 out of a floppy controller after doing wrong things for several days. And a woot from Trey Dempsey. Anyway, my brain is sleepy. I got off track. I don't remember where I was going, but heading into the weekend. Y'all have a good weekend. Relax. Be excellent to each other. And yeah, I think going back to the one chat that I missed so far, which is Roten saying, wait till you can't figure out why the code's not working, then realize you forgot to plug the chip in. That's when it's time for bed. And I feel like I'm inches away from that, so I think that's the perfect place to cut it off. So party on Garth, party on Wayne. Even though now that's the wrong movie now. And That's all I got. See ya. Love ya.